So why is it important to consider whether our test is one-sided or two-sided? Well, quite simply, the p-value depends on it. And of course, because the conclusions of our test depend on the p-value, you can understand why it is important. How does that come about? Well, remember what the p-value does, what we do with the p-value, or when we compute the p-value, is we look at what is the probability of obtaining options which are as bad as what we got or more extreme. So something as extreme or more than what we observed. Okay, let's see what that means. Let's say that this is the line that represents all the possible outcomes that we can get from our data. And let's say that the blue dot represents what we would get if in fact we noticed absolutely no difference. Okay. Now, if we notice a difference, the difference could be on the one side, maybe the side that we are hypothesizing, or not if we're doing a two-sided test, or it could be on the other side. Okay. Now, let's say that our data fall in that situation, in that position. Okay. So what the p-value does, it looks at all that range of possible options which are as far away from the null hypothesis or more. Okay. So what we look at is more extreme possible sample values, but on the same side. Okay, so the p-value then, what it does, it asks us, okay, what's the probability that we're going to fall in there? Okay, so if you look at this one, you can think of this line and this left-hand side region that we're considering as one tail of the possible range of options, and that's why this thing would be called a one-tail test. But on the other hand, when we started our test, we didn't know where the difference was going to be. It's possible that our data may have occurred on the opposite side. We may have gathered data that was as far away as what we got, but on the opposite side. And so we may want to consider also what are the options corresponding to the opposite side. What is therefore the probability of getting something which is more extreme than what we got, as extreme or more extreme than what we got, but on the opposite side. Now, notice that if we're doing a one-sided test, then we're going to collect the p-value, we're going to measure the p-value, compute the p-value only on the same side as our alternative hypothesis. However, if we're doing a two-sided test, then we're going to compute a two-sided p-value, which in fact uses both sides. We have to consider both possibilities since we are not identifying either one of them a priori as being what we expect to happen. Therefore, the p-value for the two-sided test is going to be twice as big as the p-value for a one-sided test. And you can tell that that's a big difference, right? One is double the other. So you might wonder, well, shouldn't we therefore decide ahead of time and very clearly whether we want to do a one-sided or two-sided? Of course, the answer is yes. But how are we going to do it? So when are we going to use a one-sided test? When are we going to use a two-sided test? Well, here is a fairly simple criterion that you can follow. Okay, both when you have to decide as well as to assess what the researchers in a published article have decided. So you should go with the one-sided test when the other side is either unreasonable, you know it cannot happen. Like for instance with the jumping jack and knee bend, you have a pretty good idea that knee bends can possibly be more strenuous, more exhausting than jumping jacks. Okay. Or maybe the other alternative, the other side is not really that interesting. If something happens in the other side, we don't want to know. Okay, it's not really something that that concerns us. Okay, the advantage of using a one-sided test is that we end up with a lower p-value. Remember, the one-sided p-value is half of the two-sided, so we end up with a lower p-value. Therefore, it's easier to end up with the conclusion stating yes, we are in fact seeing a difference. Our alternative hypothesis is in fact justified. But the problem is that if we end up with a surprise, if we end up with data that are actually on the other side, and the other side is equally interesting. So that would be that's why we don't want to use this if the other side is actually interesting, but only when it is uninteresting. Then we have to ignore it. Remember, we started with a one-sided, we did everything one-sided, and in order to be honest, if the data end up suggesting a conclusion in the opposite side, then we have to ignore it. On the other hand, we should use a two-sided test when either we're unsure of where the difference will occur, or simply to protect ourselves and wanting to play safe and make sure that we can make some kind of conclusion in any case, no matter what the data are going to tell us. So the advantage is that all bases are covered. The disadvantage is that we're going to end up with a higher p-value, twice as big, and therefore it's likely that some situations our p-value is not going to be low enough to allow us to say that yes, we have evidence for the alternative, but we have to rely on further data. So generally researchers use two-sided tests. They are safer. Again, they allow us to cover all bases, and they don't provide any big surprises. However, you want to check in each case what it is that they actually used. Don't assume that everybody always uses two-sided tests. Sometimes researchers do use one-sided tests, and they use so advisedly and properly.